What is a sequence? A sequence is a list in a particular order. In mathematics, we're particularly concerned about sequences of numbers. And you can see I have a sequence of numbers here. 1, 4, 9, 16, 25. Now, strictly speaking, a sequence doesn't have to have a particular pattern to it, but in math, we're mostly concerned with observing patterns, so we are going to look at sequences that have particular patterns. Hopefully, you recognize what pattern you are seeing in this sequence. Before we go on, I want to open up the official definition of a sequence and then use that along with this sequence to give you some characteristics of sequences. Our definition is that a sequence is a function whose domain is the set of positive integers and whose range is the term in the sequence. So for example, if we were to say n is the term number, and we are going to call a sub n the term. So in other words, we have a little subscript that says a sub 1, a sub 2, a sub 3, a sub 4, etc., naming the position of the terms in the sequence. We would say, let's number these terms. This is term number 1 is 1, term number 2 is 4, term number 3 is 9, term number 4 is 16, term number 5 is 25. Now, if you didn't spot what the pattern was in the sequence, hopefully you do now. So if I list the term numbers, 1, 2, 3, 4, 5, and then I list the terms, 1, 4, 9, 16, 25, you see that we do indeed have a function because every input has only one output. There can only be one term in each position in the sequence. So even if all of the terms were the same, like 2, 2, 2, 2, 2, 2, it would still be a function because each input, the term number, has exactly one output. Now we can graph these. I can make a XY graph and say that the x-axis is n and the y-axis is a sub n, or I could even call them x and y if I wanted to. However, there's a reason we call them n, and I'm going to tell you that in a minute. And list here 1, 2, 3, 4, 5, and then I'm going to make these by 5s, 5, 10, 15, 20, 25. So we will just kind of do an approximation here of our sequence. So term number 1 is 1, so it's kind of down here. Term number 2 is 4. Term number 3 is 9. Term number 4 is 16, and term number 5 is 25. Now the difference between graphing a sequence and graphing, say, a parabola or a line or a circle or some other type of graph that we've graphed in math before is that you do not connect the dots. And the reason we don't connect the dots is because n has to be an integer. There is no such thing as the 1.5 term number or the 1/3 term number. The term number has to be an integer. Now I will say that sometimes we use 0 as our starting term number, and that's okay. So strictly I guess we should say it's non-negative integers. But for the most part we start with term number 1. Now how do we write notation here? In this particular case, we could make a rule, and hopefully you recognize that these terms are all perfect squares of the term number. So if I went down and added term number n, I could say for the term that the rule for this term is n squared. So if I have term number n, a sub n would be n squared. So I'm going to write a rule for this. So for n greater than or equal to 1, a sub n is equal to n squared. This is my rule for the sequence. Now another thing we can that I want to mention is something called a series. A series is just a sum of one or more terms in the sequence. So for example, I left an E out of there. Let me try that again. I would write then this as 1 plus 4 plus 9 plus 16 plus 25 plus dot dot dot. That would be an infinite series because I'm just saying it goes on forever. Now the thing about an infinite series is I probably can't find the sum of that because it's going to get infinitely big and there's really no end to it. But I might be interested in finding what are called partial sums. A partial sum is designated, for example, S sub 1. S sub 1 is just 1. It's the first sum. It's actually not a sum in the strict sense because it's just the first term. And it's always the same as A sub 1. S sub 2, however, is the sum of the first two terms. 1 plus 4 equals 5. S sub 3 is equal to 1 plus 4 plus 9, which is 14. S sub 4 is 1 plus 4 plus 9 plus 16, which is 30, and so forth. So we can find partial sums by just adding up the designated number in the subscript of the terms in the sequence. Now, we are going to turn our attention then to some specific sequences that have some specific patterns in the next video called arithmetic sequences.